Okay, number 23. They want us to solve this when it is between 0 and 2 pi. So we're going to be using radians on this. So if we're looking at number 2, first thing we need to do is we need minus 3 from both sides. So it gives us negative 6 cosine of theta is going to equal negative 3. And then we're going to divide both sides by negative 6. So that gives us cosine of theta is going to equal 1/2. So negative 3 divided by negative 6 is going to be 1/2. So once again, we need to remember our unit circle that all students take calculus. Since we have a 1/2, that tells me that we're looking in these two quadrants right here. So we're looking in the first quadrant and the fourth quadrant. So if we look at our unit circle, so here's our unit circle. We need to find the values of cosine when it is 1/2. So those values are going to be right here and right here. Okay, so those are our two values right there. So we have pi thirds and 5 pi thirds. So theta is going to equal pi thirds and 5 pi thirds. And those are my two solutions. Okay, so 5 pi thirds and pi thirds. All right, so let's look at number 24. So if we're looking at number 24, first thing that we need to do is we need to add that 4 over. So we're going to take this 4 right here, we're going to add 4 to both sides. So that gives you negative 4 is equal to 8 cosine theta. We divide both sides by 8. And we have cosine of theta is going to equal a negative 1/2. Okay, so since we're equal to a negative 1/2, going back to this chart over here, we know that cosine is negative in these two quadrants. So that means I need to be looking in the quadrant 2 and quadrant 3. So if I pull on my unit circle chart, cosine is negative at right here, which is 2 pi thirds. So that's one of them. And the other one's going to be down here, and it's right at 4 pi thirds. Okay, so my answer in this case is going to be 2 pi thirds and 4 pi thirds. So theta is going to equal 2 pi thirds and 4 pi thirds. And those are my two solutions. Okay, number 25. First step, we're going to get rid of that. Oops, my pen got caught. There we go. First step is we're going to get rid of that plus 3. So to get rid of that plus 3, or that minus 3, we're going to add 3 to both sides. So it gives you negative 2 sine of theta is equal to negative 1. Then we divide both sides by negative 2. And we know that sine of theta is going to equal a positive 1/2. Well, I know that sine is positive in the first quadrant and the second quadrant. So I'm going to pull my unit circle. I'm going to clear off the ink here. But we're looking for when sine is positive 1/2, and that's going to be right here and right here. So for this case, theta is going to equal pi 6 and 5 pi 6. And those are my two solutions. Okay, so if we're looking at 26, we have tangent this time. First thing we got to do is we got to get rid of that minus 5. So we're going to add 5 to both sides. And that's going to give us negative 1 is equal to tangent theta. Okay, so negative 1 is going to equal tangent theta. Well, tangent you got to remember is sine over cosine. So if you get a ratio of 1, that means sine and cosine have to be the same, but different signs. So if we look at our unit circle chart, cosine are the same when you have square root of 2 over 2, or negative square root of 2 over 2, or negative square root of 2. So these are our values right here that we're looking at. Okay, so all these ones I just underlined are the ones where tangent is either going to be 1 or negative 1. Well, since we have a negative 1, we know this one right here is a positive 1, so it's not this one. We know this one right here divided by a negative is also a positive 1, so it's not that one right there. So the two values we're looking at are this one right here, 3 pi fourths, and then this one right here, 7 pi fourths. Those are the two values we're looking at. Okay, so that means right here, theta is going to equal 3 pi fourths and 7 pi fourths. And those are my two solutions. Okay, number 27. Looking at number 27, first thing I want to do is I want to get rid of that 6 out front, because I don't have the tangent, cosine, or sine isolated. The function is not isolated, so I'm going to divide both sides by 6. So I have cosine of negative 3 theta is equal to, well, I can reduce that fraction down just a little bit. I can write that as negative the square root of 2 over 2. Okay, so that 3 and that 6 can reduce down, so I have negative square root of 2 over 2. Now, the next step, since I have that negative 3 there, that tells me I need to pull up my unit circle chart, and I'm going to have to create a table. We are using between 0 and 360, so I am looking for degrees this time. And I'm looking when the cosine is negative square root of 2 over 2. So the cosine is negative square root of 2 over 2 right here and right here. Okay, so the two values I'm looking at for theta in this case are 135 and the other value is 225. Okay, so those are the two values I'm looking at. Now I have to write my equation. So it's going to be negative 3 theta equals 135 plus the period of cosine, which is going to be 360 times n. The second equation I'm going to write is going to be negative 3 theta equals, instead of 135, I'm going to make that 225 plus 360 n. And then I'm going to solve this for theta. First thing I'm going to do is divide both sides by negative 3. Okay, so when I divide both sides by negative 3, you take 135 divided by 3, and that gives you 45. So I have theta is going to equal a negative 45, and then 360 divided by 3 is going to give us 120. N. Now I didn't put the sign in front here, but what I'm going to do is we want this to be a plus sign. I know a negative into a positive is negative, but when we flip this around, we want this to be going to the right, because we do, up here it tells us we want it between 0 and 360. So if I leave it as a negative 120, that means I'm going to be going forever to the left, and that's not going to help us out. So I'm going to create myself a little table here. So this is my theta values, and let's plug in 0. If I plug in 0, that gives me 0 times 120, which gives you just 120, plus negative 40, or I'm sorry, 0 times 120 just gives you 0, plus negative 45 is a negative answer. I don't want that. So I don't have an answer there. Okay, so let's plug in 1. Okay, so that gives you 120 plus a negative 45, which gives you 75. Okay. Let's plug in 2. 2 times 120 is going to give us 240 plus a negative 45. Gives me 195. And let's plug in 3. Well, 3 times 120 is going to give us 360 minus 45 is going to give me 315. Okay, so those are my values. Now if I plug in a number bigger than that, I'm actually going to be bigger than 360, so I'm going to stop at 3. Now let's look at the second equation. The second equation, I'm going to take negative 225, whoops, and I'm going to divide that by 3, and that's going to give me 75. So I take this value right here, divide both by negative 3, so it gives me a negative 75 plus 120n. Okay, when I plug in 0, once again, I don't get a value out. And that's what theta is going to equal in, right? Theta equals, well, I'll write that for you. Theta equals that. So at 0, I get a negative number that doesn't work. If I plug in 1, that gives me 120 minus 75, which is going to give me 45. If I plug in 2, that gives me 240 minus 75, that gives you 165. And if I plug in 3, that gives you 360 minus 75, which is going to give you 285. Now if I plug in 4, it's going to be too big. So the answers for this number 27 are these values right here. So we have 75, 45, 195, 165, 315, and 285. Okay? Okay, number 28. If I'm looking at this one right here, first thing I have to do is I get rid of that 6. So I'm going to divide both sides by 6. So that gives you, I can reduce that negative 6 and that 3, which is going to give you negative square root of 2 over 2 is equal to cosine of theta plus 330. Okay, looking at this, I know the values I'm looking at, negative square root of 2 over 2. Those values are just like the last one, so the values I'm looking at are 135 and 225. And so I'm going to take theta plus 330 is going to equal 135 plus 360n. And then theta plus 330 is going to equal 225 plus 360n. So I'm going to minus 330. So you have 135 minus 330 is going to give me negative 195. So theta is going to equal negative 195 plus 360n. Well, I'm going to make n 0. That doesn't work out for me. Let's make n 1. So you have 360 minus 195, and I know my one value is going to be 165. Okay, now if we put 360 times 2 and then subtract off 195, that's going to be too big, so I'm going to stop it right there. So let's solve this other equation. I'm going to minus 330 from both sides. So you take 225 minus 330 is going to give you negative 105. So theta equals negative 105 plus 360n. What I'm going to do is plug in 0. That gives me a negative number, so I'm going to plug in 1. So that's 360 minus 105, and that comes up with 255. So my other value is 255. Now if I plug in one more value, I'm going to go too far, so I don't have to worry about that. So my two values are 165 and 255. Okay, number 29. We have to isolate the variable first. So to isolate this, what I'm going to have to do is I'm going to divide both sides by 2. And that gives us cosine of negative 3 theta is equal to negative square root of 2 over 2. Now this time, if we're looking at my unit circle, we are doing between 0 and 2 pi. So if I'm looking at my unit circle, I need to find out when the cosine is negative square root of 2 over 2. Well, that's at 3 pi fourths and 5 pi fourths. So 3 pi fourths and 5 pi fourths. So what we're going to do is set up our equation. So we have negative 3 theta equals 3 pi fourths and then plus 2 pi n, and then negative 3 theta equals 5 pi fourths plus 2 pi n. Next step, I'm going to times both sides by negative 1/3. So instead of dividing by 3, I'm going to times by negative 1/3. And I'm times this whole equation on this side by negative 1/3. So if I distribute that through, taking this negative sign, or negative 1/3 into both parts, this gives you negative pi fourths, because the 3's are going to cancel, plus 2 pi n over 3. Now that's supposed to be a negative, but I'm going to leave it as a positive because I want that to be a positive value. If not, I'm going to go too far negative. So same thing here, but this time I'm going to times by that negative 1/3, and this time I have to leave it in there. So when I times by that negative 1/3, that's going to give you 5 pi twelfths, and it's negative. And then it's going to be plus that 2 pi n over 3. Okay? So I want to get a common denominator for both of these. So to get a common denominator for both of these, the one on the left, I'm going to do twelfths. So these two right here, I'm going to times top and bottom by 3. So that gives you negative 3 pi twelfths. Plus, I'm going to times this one by 4, 8 pi twelfths. Or 8 pi twelfths n, with my n on top. Now I'm going to start plugging in values there. So if I create my little table here, so this is my theta value. If I plug in 0, that's going to give me a negative value. So I don't want that. So I'm not going to worry about that. So I'm not going to plug in 0. If I plug in 1, though, if I plug in 1, that gives you 8 pi twelfths plus 3 pi twelfths, which ends up giving you a 5 pi twelfths. So that's one of my solutions. Now if I plug in 2, get rid of that spot right there. If I plug in 2 times 8 is 16. So I have 16 pi twelfths minus 3 pi twelfths, which is going to give me 13 pi twelfths. I plug in 3. 3 times 8 is 24. 24 minus 3 gives you 21 pi twelfths. Okay, 21 pi twelfths. Now, 21 pi twelfths, there's a number that goes into both of those values. 3 goes into both those, so you can really write that as 7 pi fourths. So this right here is really 7 pi fourths. Okay? Now, let's look at this bottom one here. So I need to get a common denominator, so I really have negative 5 pi twelfths plus, and it's going to be the same as this one here. I'm times top and bottom by 4. That gives us 8 pi n twelfths. Now if I plug in 0, once again, I don't get a value out. So I don't have anything there for 0. But if I plug in 1, that gives you 8 minus 5, which is going to give you 3 pi twelfths. But 3 pi twelfths can reduce down. I can reduce that down to pi fourths. So this first value right here is pi fourths. If I make n 2, 2 times 8 gives you 16. 16 minus 5 is going to make that 11. So this one right here is 11 pi twelfths. And then if I plug in 3, 3 times 8 is going to give you 24. 24 minus 5 is going to give you 19 pi twelfths. And those are my solutions. So I end up with 6 solutions this time. So I got 5 pi twelfths, 13 pi twelfths, 7 pi fourths, 11 pi twelfths, and 19 pi twelfths. Okay, number 30. So looking at number 30, first thing I need to do is need to isolate the trig function, so I'm going to add 3 to both sides. When I add 3, that gives me 1 is equal to cosine of theta plus 3 pi fourths. So the cosine is 1. If we look up our unit circle real quick, the cosine is 1 at 0 and 2 pi. Well, I need to use 0 because 2 pi is not in my domain. Okay, so I know that my angle right here, I only have one angle this time. It's going to be theta plus 3 pi fourths is equal to 0 plus 2 pi n. Okay, so to solve this for theta, I'm going to minus 3 pi fourths over. So I end up with theta is equal to a negative 3 pi fourths plus 2 pi n. Now I really don't need to create a table here, but what I need to do is I need to get a positive value of this, because once again it's going to be between 0 and 2 pi. So if I plug in 0, I end up with negative 3 pi fourths, and that doesn't help me out. But I'm going to convert this 2 pi n to something that's over 4, so it's really negative 3 pi fourths plus 8 pi, n over 4. Okay, and I'm going to plug in 1, and that gives me 8 pi fourths minus 3 pi fourths, which gives me the answer of 5 pi fourths. So that's a 5 pi fourths. I'll just erase that top part, but it's 5 pi fourths there on top. So it is 5 pi fourths. Now if I plug in a number bigger than that, if I plug in 2, that gives you 16 minus 3 is going to give you 13 pi fourths. Now 13 pi fourths is bigger than 2 pi, because I have to stop really at 8 pi fourths, because I just take that denominator times it by 2. So that is not a solution. My only solution is 5 pi fourths. Okay, for number 31, we need to find the exact values using inverse sine of negative 1/2. Hang on one. Okay, so if we look at the unit circle, we're saying where is sine negative 1/2? Well, sine is negative 1/2 right here. Whoops, I didn't want to use a color here. So right here and right here. Now this is 7 pi 6 and this is 11 pi 6. The only problem is, or we're using degrees here, so this is 330 and 225. Neither of those values are in the domain of my sine function. Okay, inverse sine function. Inverse sine function is between negative 90 and 90. So if we're looking at this, I'm not going to be using this one over here, but I am going to be using this value right here. But we're not using 330. You have to think that we're going this direction, and since we're going that direction, it's going to be negative, and it's really a negative 30 degrees is what we've gone. So the sine inverse of negative 1/2 is going to be a negative 30 degrees. Okay. Now, let's look at cosine. So cosine inverse of square root of 3 over 2. Where square root of 3 over 2 is right here at 30 and right here at 330. Well, cosine, we're looking between values between 0 and 180. Those are the values I'm looking at. So the value of cosine of square root of 3 over 2 is 30 degrees. Okay? All right. Tangent. So when we got tangent here, tangent is the square root of 3 over 3, which I need to rewrite this as negative 1 over the square root of 3. Okay, so what we're looking for is we're looking when cosine or sine are different signs. One of them could be negative, the other one has to be positive, and one of them is 1 and the other one is the square root of 3. So sine has to be 1. So we're looking at this. This is your sine value, and this one right here is your cosine value. So we're going to look for sine is 1 and cosine is negative. So if we're looking at this right here, This gives me cosine is, or sine is 1, and cosine is negative square root of 3. If we look right here, sine is 1, and cosine, or is negative 1, and cosine is negative. Cosine is the square root of 3. Okay, so tangent, inverse tangent is defined between negative 90 and 90. So it's not this one over here. We don't want this one. But it's going to be this value here. But 330 is not in my domain, so we're going to talk about it in a negative angle. So we've gone this way, a negative degree, but we went that way 30 degrees. So our answer for this is negative 30 degrees. Okay, so remember the square root of 3 over 3 we want to rewrite as 1 over the square root of 3. The negative sign can go on top or it can go on bottom. It just depends on what problem we're looking for. Okay, number 34. So it says sine inverse of sine of 3 pi fourths. So what we're going to do is we're going to go to 3 pi fourths. So 3 pi fourths is right here. So we're looking at our sine value. Sine value is right there, square root of 2 over 2. So we have to find the other angle that's the square root of 2 over 2 because we're going to be using inverse sine. So that's going to be this value right here. Remember that since it's inverse sine is only between 90 and negative 90. That's why we couldn't use this value over here. And since they gave it two, or I should say pi halves and negative pi halves, since they gave it to me in 3 pi fourths, I do want to write this in radians. But my angle that I'm really looking at, the sine inverse, what angle we're going to get out of this, is pi fourths. Okay, so remember when it says sine inverse, your answer should be an angle. Okay, 35. We have the sine of 2 over the square root of 3. This is no solution. Okay, the reason it's no solution, 2 over the square root of 3 is greater than 1. And that doesn't work. All right. Okay, number 36, we have 4 pi thirds. So if you're looking at 4 pi thirds, here's 4 pi thirds right here. We're looking at the cosine value. So the cosine value right here is negative 1/2. So we have negative 1/2. So we have to find the other value where the angle is going to be negative 1/2. Well, cosine is also negative 1/2 right here. So we're really taking the inverse cosine of negative 1/2. Cosine is defined between 0 and 180. Therefore, the value that we're looking at right here is going to be right here, the value 2 pi thirds. We can't use 4 pi thirds because that's not in the domain of the inverse cosine. So right here, it is going to be 2 pi thirds. Okay. Okay, number 37, the sine of 90. Well, here's 90 right here. The sine of it is 1. So we're really looking at the tangent inverse of 1. Well, that means when the sine and cosine are the exact same. Well, sine and cosine are the exact same right here and right here. 225 is not in the domain of my inverse cosine. Therefore, my value that I'm looking at is going to be 45. Or since we start out with degrees, we're going to end up in the degrees, but it's 45 degrees. Okay, number 38. It says sine inverse of 1/2. So what you're looking at is you're looking at a triangle. Oh, that was a bad triangle. Let's start that over. So I'm looking at a triangle. Okay, so my right angle is right here. I'm going to call this angle A for fun. So if we're looking at the sine of this, it's going to be opposite, which is 1, over the hypotenuse, which is 2. And then we're going to have to use Pythagorean theorem to find this other side. So we have 2 squared equals 1 squared plus, and I'm going to call this b squared for fun, b squared. So that gives us 4 is equal to 1 plus b squared. We minus 1 from both sides, and we get 3 is equal to b squared. We square root both sides, and b equals the square root of 3. What we need to find now is the cosine. Cosine is adjacent over hypotenuse, so this is going to equal the square root of 3 over 2. And that's my solution. Okay, number 39, if I'm drawing my triangle, looks something like this. So I'm going to have my right angle right there. Cosine is going to be 5, which is my adjacent, over my hypotenuse right there. Okay, and that's my angle A. So that's going to be 5 over 13. Okay, now I have to find this side over here, so I'll call this A. So I have A squared plus 5 squared is equal to 13 squared. Well, that gives me A squared plus 25 is equal to 169. You minus 25. And you end up with A squared is equal to 144. You square root both sides, and A is going to equal 12. Now we're looking for tangent. Tangent is opposite over adjacent, so that's going to give you 12 over, whoops, not 5, whoops, 12 over, was writing 15, but it's 12 over 5. And that is my ratio. There's my 5. Okay, so 12 over 5 is my answer. Okay, so for number 40, if I'm drawing my triangle, it looks something like this. Here's my right angle. This is 11. This is 15. This is the angle we're looking at. So it's opposite over adjacent. So if I'm using Pythagorean theorem, this is going to give me 11 squared plus 15 squared is equal to c squared. And I'm going to call this side c. So that gives you 121 plus 225 equals c squared. So that gives you, one second. So that's going to give us 346. So we get 346 is equal to c squared. We square root both sides. And c is going to equal, now the square root of 346 is like 18.6. So the exact form would have like the square root of 364 in it, but that's kind of messy. So I'm going to write it as 18.6. So sine of that is going to equal 11 over 18.6, which if you type that into your calculator, that gives you 0.5914. Okay, so there's the test review for you. So I hope you do well. If you have any questions, please come in and see me.